Since the dawn of humanity, we have looked up at the stars with wonder, curiosity, and ambition. What lies beyond the skies? What mysteries does space hold? This is the story of our greatest adventure, the exploration of space. Welcome back to Deep in Space, the channel where we go on an extraordinary journey to discover the mysteries of the universe. I'm your host Salman Sahil, and today we'll jump into the enthralling world of space exploration, where the limits of human knowledge are constantly expanding. Our journey begins with a brief look back at the incredible history of space exploration. From the early days of simple rockets to the monumental Apollo missions that landed humans on the moon, humanity has always reached for the stars. The history of space exploration is a fascinating journey that showcases humanity's curiosity, innovation, and determination to explore the cosmos. The foundation of space exploration can be traced back to the development of rocketry in ancient China. The invention of gunpowder and the subsequent creation of simple rocket devices laid the groundwork for future advancements. During World War II, German engineer Werner von Braun led the development of the V-2 rocket, a groundbreaking technology that became the world's first long-range guided ballistic missile. The V-2 rocket marked a significant leap in rocketry and laid the groundwork for future space exploration. The Cold War rivalry between the United States and the Soviet Union fueled the space race, a period of intense competition to achieve significant space exploration milestones. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite, into orbit, marking the beginning of the space age. In 1961, Yuri Gagarin became the first human to orbit the Earth, a monumental achievement for Soviet space exploration. The United States responded with the Apollo program aiming to land humans on the moon. The Apollo program led by NASA achieved its goal with the historic Apollo 11 missions in 1969. Astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the moon. With Armstrong's famous words, "That's one small step for man, one giant leap for mankind." Space exploration would not be possible without incredible inventions and technology. Over the decades, we have built machines capable of taking us to new worlds, observing distant galaxies, and even living in space. The Voyager missions, launched in 1977, were designed to explore the outer planets of our solar system. Both Voyager spacecraft provided unprecedented images and data of Jupiter and its moons. Voyager 1 discovered Jupiter rings, while Voyager 2 revealed details about the Great Red Spot and the volcanic moon Io. They made detailed observation of Saturn, its rings, and moons. Voyager 2 continued its journey to Uranus and Neptune, providing the first close-up images of these planets. It discovered new moons around Uranus and observed Neptune's great dark spot. After completing their primary mission, both Voyager spacecraft continued on an extended mission into interstellar space. Voyager 1 became the first human-made object to enter interstellar space in 2012. Each Voyager spacecraft carries a golden record, a photograph record containing sounds and images selected to portray the diversity of life and culture on Earth. This was intended as a message to any extraterrestrial intelligence that might encounter the spacecraft. Both Voyager 1 and Voyager 2 are still operational and continue to send back data from the outer reaches of our solar system. Now let's focus on the red planet Mars. Our curiosity about Mars has led to groundbreaking missions like the Perseverance rover, searching for signs of past life and preparing for future human exploration. Will Mars be our next home? The fascination with Mars as a potential human settlement has been a driving force behind numerous space missions. The Perseverance rover, launched by NASA on July 30, 2020, has been a game changer in our understanding of Mars. Equipped with advanced scientific instruments, Perseverance's primary goals include studying the Martian geology, assessing its past habitability, and importantly, searching for signs of ancient microbial life. Mars has a thin atmosphere composed mostly of carbon dioxide with traces of other gases. The thin atmosphere is a challenge for human colonization because it provides minimal protection from harmful solar radiation. Engineers and scientists are actively exploring ways to address these challenges, including potential terraforming projects to thicken the atmosphere and make it more Earth-like. Water is essential for human survival, and Mars has vast reservoirs of water ice. The discovery of water beneath the surface and the polar ice caps makes Mars a more valuable candidate for future human habitation. Scientists are exploring ways to extract and utilize these water resources for drinking water, agriculture, and fuel production. Sustainable colonization would require the ability to grow food on Mars. Scientists are experimenting with growing plants and simulated Martian conditions on Earth to understand how crops could thrive in the red planet's unique environment. Advanced hydroponic and aeroponic systems are being developed for potential future Martian farms. While Mars holds promise, there are significant challenges. The harsh surface conditions, including dust storms, extreme temperatures, and radiation exposure, pose obstacles to long-term human settlement. Space agencies and private companies are working on technologies to address these challenges, including developing radiation shields for habitats and spacesuits and designing durable, self-sustaining habitats. SpaceX, founded by Elon Musk, has been at the forefront of advocating for Mars colonization. Musk envisions creating a self-sustaining city on Mars to ensure the survival of humanity in case of catastrophic events on Earth. The Starship spacecraft, currently in development, is intended to be a key component in SpaceX's ambitious plans for interplanetary travel. In conclusion, Mars represents an exciting frontier for exploration and potential colonization. While numerous challenges must be overcome, the collective efforts of space agencies, scientists, and visionary entrepreneurs are pushing the boundaries of what is possible. The dream of humans living on Mars is gradually becoming more tangible with each mission and technological advancement. The future holds the promise of unlocking the mysteries of the red planet and perhaps making it a second home for humanity. The Hubble Space Telescope is a space-based observatory launched into low Earth orbit in 1990, jointly operated by NASA and the European Space Agency. Hubble has been instrumental in revolutionizing our understanding of the cosmos. Equipped with powerful instruments, Hubble has provided high-resolution images, and conducted a wide range of observation in the optical and ultraviolet spectra. Its location above Earth's atmosphere allows for clear and more detailed observation of celestial objects, from studying planetary atmospheres to unraveling the mysteries of dark matter and dark energy. Hubble has profoundly impacted our understanding of the cosmos. Serviced by astronauts on multiple missions, this space telescope continues to unveil the wonders of the universe and inspire awe and curiosity among scientists and the public alike. Over the years, the telescope has undergone servicing missions to extend its operational life and enhance its capabilities. One of the most significant collaborative efforts in space exploration is the International Space Station ISS. It serves as a microgravity laboratory for scientific research and international cooperation in space. It travels at a speed of about 28,000 kilometers per hour, completing an orbit around Earth approximately every 90 minutes. The ISS is a collaborative project involving multiple countries, including the United States, Russia, Japan, Europe, and Canada. The ISS consists of interconnected modules that provide living space for astronauts, scientific laboratories for conducting experiments in microgravity, and solar panels for generating power. It serves as a platform for research in various fields such as biology, physics, astronomy, and materials science. Astronauts aboard the ISS conduct experiments that help us better understand the effects of long-duration space travel on the human body, study Earth's environment from space, and develop technologies for future space exploration missions. The ISS has been continuously inhabited since November 2000, with astronauts from different countries living and working together in space. It symbolizes international cooperation in space exploration and has been crucial in advancing our knowledge of living and working in space. As plans for future space exploration missions evolve, the ISS remains an essential asset for conducting scientific research and preparing for future human missions beyond Earth's orbit. One of the most profound questions in space exploration is, are we alone? With thousands of exoplanets discovered in the habitable zones of distant stars, scientists are getting closer to finding planets that could host life. Exoplanets are planets outside our solar system have become a focal point in the search for extraterrestrial life. Astronomers use various methods such as the transit method and radial velocity method to detect exoplanets by observing the tiny changes they induced in the light of their parent stars. The habitable zone, often referred to as the Goldilocks zone, is an area around a star where conditions may be suitable for liquid water to exist, a key ingredient for life as we know it. For this purpose, NASA launched a space observatory known as Kepler, designed to search for exoplanets, which are planets orbiting stars outside our solar system. Launched in 2009, the Kepler Space Telescope monitors a specific region of the Milky Way galaxy to detect the tiny periodic dips in brightness that occur when a planet passes in front of its host star, known as a transit. By observing these transits, Kepler was able to identify thousands of exoplanet candidates, ranging from rocky planets to gas giants, orbiting a wide variety of stars. The mission significantly expanded our understanding of planetary systems beyond our own and provided valuable data for studying the diversity of exoplanets in our galaxy. One of Kepler's notable achievements was the discovery of Earth-sized planets within the habitable zones of their stars, where conditions might be suitable for liquid water to exist on the planet's surface, a key factor in the search for potentially habitable worlds. Although the Kepler spacecraft officially ended its mission in 2018, the data is collected continued to analyzed by scientists worldwide, contributing to ongoing research in exoplanet science and the search for worlds that may harbor signs of life beyond our solar system. The search for alien life extends beyond planets. Organizations like SCTI use radio telescopes to listen for potential signals from intelligent extraterrestrial civilizations. Scientists involved in SCTI use various methods to search for signals or evidence of technological civilizations in the universe. One common approach in SCTI is the search for radio signals or other electromagnetic transmissions that could indicate the presence of advanced extraterrestrial civilizations. Radio telescopes are used to scan the sky for any unusual or artificial signals that could potentially originate from intelligent beings or other planets. Another method involves looking for potential biosignatures in the atmospheres of exoplanets, which are chemical indicators that could suggest the presence of life. Scientists analyze the light passing through the atmosphere of distant planets to search for specific molecules that may be produced by living organisms. SCTI research is a fascinating and ongoing field that aims to answer one of humanity's most profound questions: are we alone in the universe? While no definitive evidence of extraterrestrial intelligence has been found yet, scientists continue to explore new techniques and technologies in the search for signs of alien life. Fast forward to the present, and we find ourselves in an era of cutting-edge technologies. Advanced spacecraft like the James Webb Space Telescope are pushing the boundaries of what we thought was possible. The James Webb Space Telescope is one of the most anticipated and advanced space telescopes ever built. Launched on December 18, 2021, the James Webb Space Telescope represents a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. It is positioned at the second Lagrange point, about 1.5 million kilometers from Earth. The James Webb Space Telescope aims to answer fundamental questions about the origins of the universe, the formation of galaxies, and the conditions necessary for life. Telescopes like the James Webb Space Telescope are designed to analyze the atmospheres of exoplanets. The presence of certain gases such as oxygen and methane could be indicative of biological process. Observations of biosignatures, which are molecules associated with life, contribute to our understanding of the potential habitability of exoplanets. It observes distant galaxies and explores the mysteries of dark matter and dark energy. The history of space exploration reflects humanity's persistent desire to push the boundaries of knowledge and explore the vastness of space. From humble beginning with early rockets to the ambitious plans for future exploration, the journey into the cosmos continues to evolve, opening new chapters in the ongoing story of our exploration of the universe. As we dream big, the prospect of interstellar travel captures our imagination. We'll delve into the exciting concepts and ideas that scientists and visionaries are exploring for traveling beyond our solar system. Interstellar travel, the concept of journeying between stars, is a subject that has captivated the imagination of scientists, engineers, and science fiction enthusiasts for decades. While interstellar travel remains a formidable challenge, several exciting concepts and ideas are being explored to make this dream a reality. The primary challenge in interstellar travel is the vast distances between stars. Conventional rocket propulsion systems like those used for missions within our solar system are not sufficient for the immense distances of interstellar space. Scientists are researching and developing advanced propulsion systems to achieve higher speeds and reduce travel time. One proposed solution involves using nuclear-powered engines, such as the concept of nuclear thermal or nuclear electric propulsion. These systems could provide higher thrust and efficiency compared to chemical rockets. Another intriguing idea is light sail technology, where spacecraft harness the momentum of photons from a powerful laser or a natural light source. This concept, inspired by the work of physicist Robert Forward, relies on a large, lightweight sail to catch and reflect light, propelling the spacecraft forward. Ion propulsion, already used in some space missions, involves expelling ions at high speeds to generate thrust. While not currently capable of achieving interstellar speeds, ongoing research aims to enhance the efficiency and power of ion propulsion system. Breakthrough Starshot is a visionary interstellar exploration initiative aimed at sending small, lightweight spacecraft to the nearest star system Alpha Centauri with a human lifetime. The project was announced in April 2016 by the Breakthrough Initiatives, a program funded by Russian billionaire Yuri Milner and physicist Stephen Hawking. The primary goal of Breakthrough Starshot is to develop and launch a fleet of nanocraft, tiny-gram-scale spacecraft equipped with advanced technology to travel at the significant fraction of the speed of light. The initiative seeks to achieve this ambitious feat through the use of powerful laser for propulsion. The proposed spacecraft would be propelled by a ground-based laser array known as a light sail, which would propel the nanocraft to speed up to 20% of the speed of light. At such speeds, the journey to Alpha Centauri, located approximately 4.37 light years away, could be completed in just over 2 decades. The nanocraft would be equipped with various instruments, including cameras and communication systems, to collect data and send it back to Earth. The scientific objectives of Breakthrough Starshot include studying the characteristics of exoplanets and Alpha Centauri system and searching for potential signs of life. Breakthrough Starshot faces numerous technological challenges, including the development of extremely lightweight yet robust spacecraft, efficient laser propulsion system, and reliable communication over interstellar distances. Despite these challenges, the initiative represents an ambitious and forward-thinking approach to interstellar exploration, pushing the boundaries of current space exploration capabilities. The concept of Webb drive, particularly popularized by the Elco Drive, is a speculative idea rooted in theoretical physics, specifically within the framework of general relativity, proposed by physicist Miguel Alcubierre in 1994. The Alcubierre drive suggests a method for achieving faster than light travel without violating the principles of relativity that forbid objects with mass from reaching or exceeding the speed of light in a vacuum. The Alcubierre drive involves the creation of a Webb bubble around a spacecraft. Instead of moving the spacecraft itself, this theoretical propulsion system would contract space in front of the spacecraft and expand space behind it. The spacecraft would remain within a flat region of space-time, known as the Webb bubble, where the effects of relativity would not apply. This contraction and expansion of space-time would be achieved by specific configuration of a negative energy density, often referred to as exotic matter. This exotic matter, which has negative mass energy, is theoretically necessary to wrap space-time in the manner proposed by Elco Drive. If we succeed in obtaining the Webb Drive technology, then we can travel from Earth to Proxima Centauri in just 6 months. While the Elco Drive is an intriguing concept, there are significant challenges and open questions associated with its practical implementation. One major concern is the lack of known exotic matter with the required properties, and there are debates about the feasibility and stability of the Webb bubble. Additionally, issues related to the potential accumulation of particles in front of the spacecraft during its journey have been raised. The Elco Drive remains a theoretical concept and has not been demonstrated or implemented. It serves as a fascinating topic for discussions on the potential future of space travel and exploration beyond the limitation of conventional propulsion systems. Research in this area continues, but it is important to note that achieving Webb Drive capabilities would require advancements that go far beyond our current understanding of physics. Generationships are hypothetical spacecraft designed for long-duration interstellar travel, where the journey spans multiple generations of inhabitants. Unlike the more speculative Webb drives of faster-than-light propulsion concepts, generationships take a more conservative approach by relying on currently understood principles of space travel. Generationships are envisioned as massive self-contained ecosystems that provide everything needed for human survival or extended periods. These habitats include living quarters, agriculture areas, recreational spaces, and all the necessary systems for waste management, energy production, and life support. The primary purpose of Generationships is to enable human colonization of distant star systems. These ships are designed for journeys that would span centuries, with the expectation that the original crew who initiated the mission would not be alive to witness its conclusion. Instead, successive generations of inhabitants would be born, live, and die during the voyage. Given the extended duration of the journey, maintaining a stable social structure becomes crucial. Effective governance, education systems, and mechanisms for conflict resolution must be in place to ensure the well-being and functionality of the community over the generations. To sustain life over such long periods, generationships must rely on closed ecological systems. These systems recycle air, water, and nutrients to create a sustainable environment. This requires careful planning to avoid depletion of resources or the accumulation of harmful products. The technologies employed in generationships must be highly reliable, as there would be limited opportunities for repair or resupply during the journey. Advanced life support systems, robust energy sources, and closed-loop ecological systems would be essential. Living in the confined space of a generationship for an entire lifetime poses physiological challenges. Strategies for maintaining mental well-being, addressing potential feelings of isolation, and fostering a sense of purpose are critical. While the concept of generationship is more grounded in known physics compared to some other interstellar travel proposals, the immense challenges and ethical considerations make their practical implementation highly complex. The construction and launch of generationships remain firmly in the realm of science fiction. However, discussion about the feasibility and ethical aspects of such endeavors continues to enrich the discourse of humanity's potential future in space. Interstellar travel requires advancement in material energy storage and life support systems. Researchers are exploring materials that can withstand the harsh conditions of space and developing technologies that minimize resources consumption over extended periods. While the challenges of interstellar travel are immense, the pursuit of these concepts sparks innovation and pushing the boundaries of our understanding of physics and engineering. The dream of reaching distant star system remains a driving force in scientific exploration, and as technology continues to advance, humanity may one day embark on the incredible journey of interstellar travel. Space exploration has changed our understanding of the universe and our place in it. It forces us to confront deep physiological questions about existence, the nature of reality, and the future of humanity. Seeing Earth from space as a fragile blue marble in the vastness of the universe has inspired generations to rethink our relationship with our planet and each other. As we continue to explore space, we are constantly reminded of our smallness and the grand scheme of things. Yet, our curiosity and ambition drive us to reach out beyond the stars, searching for meaning and understanding. Our journey into space has just begun. We have only scratched the surface of what's out there waiting to be discovered. As we venture deeper into the cosmos, the story of space exploration will continue, driven by our instability, curiosity, our quest for knowledge, and our ending hope that one day we may find our place among the stars. Thanks for joining me on this epic journey through the history and future of space exploration. From the early days of rocketry to the ambitious plans for interstellar travel, we have covered it all. If you like this video, be sure to like, comment, and subscribe to Deep in Space for more content that's out of this world. Join me next time as we explore more mysteries of the universe and push the boundaries of human knowledge. Until then, keep looking up at those stars and wondering what's out there and what secrets the universe holds.